right, so let's take a look at section 7.6. Okay, 7.6 is on solving trig equations using different identities with algebra, okay, without graphing. So some of the techniques we're going to use, pretty much every problem, factoring, okay, rewriting a problem so that it just uses one trig function. So if you have a mixture of different kinds of trig functions, we'll try to rewrite it with just one. And what did you do in algebra 1 when you couldn't factor a quadratic? How can you solve it if you can't factor? Augustine? Yeah, we can use the quadratic formula. Okay, just remember, when you use the quadratic formula, if you have something like box squared plus box plus a constant, you're solving for basically box equals. Right? So if it was x's, like x squared plus x plus 6 equals 0, you're solving for x equals. Okay? If it's sine squared plus sine plus 7 equals 0, you're solving for sine equals. So in that last step, we got to remember, we got to get x by itself still. Okay? So you're solving, these would have x's. You're solving for whatever that middle thing is. But we still have to get x by itself in the very last step. Okay, so any questions on recognizing a quadratic pattern, which is anything that looks like that? All right. But again, you only have to use the quadratic formula if you can't factor. So always try that first. All right. So this one says find all solutions between 0 and 2 pi. It's 2 cosine squared x plus sine x plus 1 equals 0. Now some people may say, oh, it looks good. You can use the quadratic formula. You've got something squared, then something, and then a constant. Why can't you use the quadratic formula the way that is? Yep.
Because it's using different functions.
Right, it's using different functions. It's like if I said 2x squared plus y plus 1 equals 0. You can't use the quadratic formula on that. You're using different variables. All right, so first thing we got to do is we got to get all our trig functions in terms of the same trig function. And I'm giving you a hint to use the Pythagorean identity sine squared plus cosine squared equals 1. Okay, Joe, in that identity, is there anything there out of those three parts that appears up above it?
Cosine squared?
Yeah, the cosine squared. The 1 does too, but leave the 1 because that's the constant. The cosine squared. Okay, Cody, what's cosine squared if you solve it in that trig identity? So instead of having 1 by itself, I want to get cosine squared by itself. So anything that's not a cosine squared, put it on the other side.
Oh, it would be sine squared plus 1.
How would you move sine squared to the right? What would you...
Oh, divide that, right? Subtract it.
Subtract it, because you have addition here. So the way we undo addition is with subtraction. So cosine squared, go ahead, Darren, would be
1 minus sine squared.
1 minus sine squared. So we're going to make that substitution. Change cosine squared to 1 minus sine squared. Put it in parentheses because you're doubling something that has more than one term, so that's a distributive property. Keep the sine x, keep the plus 1. Now I'm going to distribute. Okay, James, what's 2 times 1? 2 plus 1, 3. So let's do all that in one step. So there's my constant. I get 2 times negative sine squared is negative 2 sine squared plus sine x plus 3. Now, there's a problem here if we want to try factoring. Okay, we have to do something to all 4 parts here if you want to factor it. This is basically like trying to factor this. What would be your first step if you were going to factor this equation in Algebra 1? You wouldn't do it the way it's written there. You would change something. It's in the right order. You get the x squared, the x, and the 3. Something's not right. Yeah? Right, we got to get rid of the negative. Okay, anytime you want to factor, you want the x squared positive. So Brielle, how could I get rid of that negative? Yeah, you could factor out a negative 1 or just multiply everything by negative 1, divide everything by negative 1. Same idea. Point is change the sign of everything. Okay, now we're going to try to factor that. Factoring this is just like factoring this. You can factor 2x squared minus x minus 3, okay, and write the answer down. Whatever you have for x's, when we're done, we have to erase it and fill in sine x, because it's not really x, it's sine x. But visually, some people just find this easier to look at. Okay, let's try to factor. Okay, what's going to be my first term in each parenthesis? Andy?
X.
Okay, we're going to need an x in one of them, if we're doing it, and then what else? So if you put an x in one, what would you have to put in the first one so that when you multiply them together, you get 2x squared?
X squared.
No, x and x squared would multiply to give me x cubed. So that wouldn't work. Oh, Colby? No? 2x and x. So 2x and x. And what is x really, though?
1.
Well, it's not really x. Remember, this is not really the problem we're solving. X is really... Well, x squared is sine squared, but x is just sine x. Okay, so all we did was change sine x to x to make it easier. But let's try to factor the real problem we're doing. So that's like my 2x and x. Okay, now I look at my signs. Emily, I have a negative middle, negative constant. What are my signs going to be?
Plus and a minus.
Okay, we need a plus and a minus. We can try them in that order. If it doesn't work, we can always switch them. And now 2 numbers that multiply to give me 3. Brielle?
2, 3, 3,
1 and 3. Okay, that's the only choice we have. Okay, I put it in the order that she said, 1 and 3. Let's see if it works. So we get 2 sine x times 3. That's 6 sine x minus 1 sine x. James, did that give me what I wanted in the middle? No. Let's try switching the 1 and the 3. Now I get 2 sine x times 1. That's 2 sine x. Take away 3 sine x. 2 take away 3. That is negative 1. Okay, so now I've got the middle. And then negative 3 times 1 is negative 3. Okay, so that's good. So we factored it. And now, Darren, if I multiply 2 things together and I get 0, how does that happen? One of them has to be 0. either that one or that one. Okay, now we'll solve each one. Okay, Brianna, what would be my first step to get sine x by itself?
Divide by 2, or add the 3 to 7.
Add the 3, yep, and then divide by 2. So add the 3, and then divide by 2. Okay, Jill, what is that number, 3/2 as a decimal? 1.5. So you're trying to figure out where the sine equals 1.5. Any thoughts on that? Think of the sine function when you graph it, just the basic sine function, and where it would hit 1.5. Yeah? Yeah, it wouldn't. Sine only goes up to 1. So your next step here would have been to try taking the inverse sine of each side, but that's not going to work. Sine doesn't go up to 1.5. So from this part, you don't get any answers. Okay, we still have to look at the other part. So sine of x equals -1. Since it's equal to -1, I would just try to draw the graph and visualize where that is. So 0, 90, 180, 270. Or 3 pi over 2. So for this problem, the only answer is 270 degrees or 3 pi over 2. Okay, if you weren't sure, you didn't understand how to do the graph, you can use your calculator. You plug that in, it's going to tell you -90. But my directions said find answers between 0 and 2 pi. Okay, so if you have -90, just add 360 to it. And that makes it 270. And then convert to radians. Okay, any questions on that? All right, let's try this one. Okay, so this one is very similar. It just has one extra step. Anytime you're solving this kind of equation, Casey, what should it be equal to? It should be equal to 0. Okay, so your first step is just move everything to the other side. So you've got 2 sine squared x minus cosine x minus 1 equals 0. Now it's exactly like the last problem. Okay, James, which trig function here do you think we're going to change? Sine squared or cosine?
Sine squared.
Yep. We're going to substitute in something for sine squared. Okay. Using the trig identity we just had on the other page, instead of cosine squared equals, anyone tell me what sine squared would equal? Oh, Augustine? What would sine squared equal?
1 minus cosine
Good. 1 minus
squared.
cosine squared. Yeah. So that's the substitution we're going to make. We'll distribute it, combine like terms for the constant. So you're going to get 2, take away 1. That's a plus 1. You're going to get a -2 cosine squared minus cosine x. And now we're going to do the same thing we did last time. Divide everything by -1 so we can get that squared term positive. So 2 cosine squared plus cosine x minus 1 equals 0. Okay, so you're basically trying to factor that. Okay, if it helps you to think of it that way, you can think of it that way kind of temporarily. But just remember that x isn't really x. It's cosine x. Okay, so Jill, what would be my first term? My first term in the first parenthesis.
2 cosine?
Yeah, it would be like 2x or 2 cosine And in the next parenthesis, my first term,
Cosine.
just cosine. Yeah, it's like having 2x and x. Now looking at, I've got a positive middle, negative constant. I'm going to need one of each. If it's not right, we'll switch the order. And now two numbers that multiply to give me 1. Well, I don't have any choice with the ones. So the only problem here could be the signs. And I don't think the signs are right. So you get 2 cosine squared minus 2 cosine plus 1. Minus 2 plus 1 is minus 1. So we just need to switch the signs. Now we get 2 times 1 is 2. Minus 1. 2 take away 1 is positive 1. And that's equal to 0. So set each factor equal to 0. Okay, I'm kind of going to do one of the steps in my head. 2 cosine x minus 1 equals 0. Plus the 1. And then divide by the 2. Cosine x plus 1 equals 0. Minus the 1. Okay, Alex, how would I get rid of cosine so I get x by itself?
Inverse cosine?
Good. Inverse cosine. Or x equals inverse cosine of negative 1. Okay, let's type that in. Okay, hopefully we already know this is a nice answer. Thinking of what angle do you take the cosine of and get 0.5 is the answer. If you're not sure, you can check. 60, okay, or pi over 3. Now we're looking where cosine is positive, so that happens one other spot. Kobe, what's the other quadrant where cosine is positive? 4, quadrant 4. So take your reference angle, and Andy, what do you do with your reference angle to get an answer in quadrant 4?
Subtract it from 360.
Good, subtract it from 360. So that's 60. Subtract that from 360, you get 300, or 5 pi over 3. Okay, the way I change 300 degrees to radians so fast is pi over 3 is 60. Okay? I'm trying to get 300. What do you multiply 60 by to get 300? Multiply it by 5. So I just took pi over 3, times it by 5, and that makes it 300. Okay, and my last answer, for this one, I just tend to think of the graph. Cosine starts at the top. 0, 90, 180. 270, 360. So it hits its lowest point at pi. Okay, go back up and make sure that all your answers are in the domain they wanted. Okay, they said find all solutions in one period. They didn't give us a domain. So we got to make sure that those are all within one period. Okay, Jill, what's the period of cosine?
Pi.
No, not pi. The period of tangent is pi. Cosine is a little bit longer of a period. 2 pi. Okay, so cosine is 2 pi. If you remember when we talked about raising trig functions to powers, sine squared is pi. So the least common multiple between pi and 2 pi is 2 pi. So you have to find all the answers within an interval of 2 pi. I think the easiest interval to do is that one. If you wanted to go negative pi to positive pi, that's also appropriate, but I think that's easier. So that's one period. All those answers are within the interval I just wrote. So they're all correct. Okay, this part I just want you to look at. Okay, I want you to keep in mind that really if you find one solution, there's infinitely many solutions, but we're not writing it that way in this section. Okay, we've done this before. You find one answer, and then you put period times n. Well, we might have used k, like plus 2 pi k, plus pi k. We're not doing it that way this time. We're just finding all the answers within whatever interval they tell us to look at. Okay. But I just don't want you to forget about how we did it before. Okay, so we're looking for all answers here between 0 and 2 pi. And we have tangent x equals 3 cosine x. Okay, we've got to substitute in for one of these trig functions. Okay, Emily, which trig function do you think we're going to try to change here? Tangent or cosine?
Tangent.
Yeah, tangent's the more complicated one. Cosine is already pretty simple. I mean, you can't really change cosine to much else. Sine and cosine are very, very basic. So we're going to change tangent. Anybody tell me, how can you rewrite tangent? Try to use, if you can, a trig function that already appears in that equation. Yeah? Yeah, you can write it as sine over cosine. So my next step, I want to get rid of this denominator. I want to get rid of dividing by cosine. So Colby, what would I do on each side to undo dividing by cosine?
Multiply by cosine.
Yeah, multiply by cosine. Now you should be looking at something that's starting to look familiar. We're going to bring everything to one side. And we're going to have to make one more substitution for the trig function that's squared. Actually, yeah, I think we're still going to have to do a substitution. Okay, so I subtracted sine x. Okay, let's substitute for cosine squared. James, can you remind me again, what's cosine squared the same as?
1 minus sine squared.
Yeah, 1 minus sine squared. Okay, do your distributive property. So we get 3 times 1 is positive 3. I'm going to put the constant at the end. Minus 3 sine squared. Minus sine x. Okay, again, I want to undo that, get rid of that negative. So divide everything by negative 1. And we're basically trying to factor this. 3x squared plus x minus 3. Okay, I won't waste too much time with that, but you can't factor that. You can try. Like if you try 3x and x, and then your signs have to be one of each. And 2 numbers that multiply to give me 3 are 1 and 3. No matter, you could try switching the 1 and the 3, that won't work. You could try switching the signs, that won't work. You can't factor this one. So since we can't factor it, what else can we use to solve it? Oh, Cody? Yeah, quadratic formula. Okay, so write down your A, B, and C. And remember, we're not solving for x. When we're done, we're going to get sine x equals. Okay, in fact, I'll write it. We won't round it off. So sine x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now we have minus a minus, so that becomes a plus. And we're going to get 4 times 3 is 12, times 3 is 36, plus 1 is 37. So that's what sine x equals. Okay, let's just split it apart. So sine x equals -1 plus square root 37 over 6. And sine x equals -1 minus over 6. Okay, let's check the decimal for -1 minus, whoops, square root of 37 over 6. In fact, well, we may not even need to check the decimal. Can somebody give me a kind of a rough idea? What's the square root of 37 about? Or it's a little bigger than what?
6.
It's a little bigger than 6. So if you take -1 and you subtract something a little bigger than 6, you're going to get something a little bigger than -7. If you take let's just even say -7 and divide by 6, you get a number that's just a little bit bigger than what? So it's a little bigger than -1. Okay, if you had to, you could type that in and see that. Does sine of x ever go beyond -1? No. This number is bigger, if you were to think of it on a number line, it's to the left of -1. It's like -1.1. Okay. So that won't work. The other one will. Okay. To get x by itself, you're going to use inverse sine. And we'll type in second inverse sine, -1, plus the square root of 37. Okay, and what I did is I put the numerator in parentheses just in case it had a problem with order of operations, and divide by 6. Okay, so I get 1.01. And again, there's two quadrants where sine can come out to a positive number, which if you type this in, -1 plus the square root of 37, that's positive. And then divide by a positive, it's still positive. Okay, so we've got an answer in quadrant 1. I'm looking for an answer also in quadrant 2. So how would I get my answer in quadrant 2?
Doesn't that not work either?
No, this number it does work.
Why?
Because if you plug this in, this is like -1 plus about 6.1. So -1 plus about 6.1 is 5.1. And then 5.1 divided by 6, it's like 0.8 something. So if you type this in as a decimal, you do get a decimal less than 1.
There's nothing why is it 1.1?
That's the answer. That's fine. That's 1.01 radians. That's the angle. Remember, the angle can be anywhere from 0 to 2 pi, 0 to 6.28. So 1.01 is between 0 and 6.28. So that's okay. The -1 to 1, that's different. You're looking at the argument, not the final answer. Okay, so what do you do with this angle to get an answer in quadrant 2? Priya? Yep, subtract it from 180, or in radians, subtract it from pi. Okay, so pi minus 1.01. Oops. Pi 2.13. And again, that answer is also between 0 and 6.28, so that's fine. So there's one where you have to use your quadratic formula. That one I'm going to skip over. Very similar to the other two, you're either going to have to factor or use quadratic formula. Okay, let's try this one. Notice the domain, they're looking for -90 to 90. -1.57 in radians up to +1.57. Keep that in mind. All right, so Alex, what's the first thing I should do here? If I'm trying to solve this equation, I need to get it equal to what? 0. So how would you move both of those to the other side?
By subtracting.
Yeah.
Plus. So you can't.
So we're going to subtract, yeah, subtract your secant squared, subtract your 1. I changed the order just because I like to have the highest exponent first, the next exponent, and then the constant last. Okay. Problem here is we've got two different trig functions. Okay, Brielle, which one do you think we're going to try to plug in for? You think we're going to change tangent to the fourth, or are we going to try to change secant squared? One of those we actually have a trig identity for. Remember which one appears in a trig identity? Is it tangent to the fourth or secant squared? Yeah, it's secant squared. There's an identity for that. Anybody remember what secant squared is? That's our trig. If not, you can go back and look that up on that page with all the identities. It's a Pythagorean identity. So it should be in the same spot as like the sine squared plus cosine squared equals 1. James, you think you got it?
1 plus tangent squared.
Yeah, 1 plus tangent squared. So make sure you do have that somewhere. Okay, secant squared is 1 plus tangent squared. Now I have everything in terms of tangent. Okay, let's distribute out your negative. So 3 tan to the fourth minus tangent squared. Minus 1 is minus 2. Okay, we want to try to factor that. You could use quadratic formula because the 4 is double the exponent of the middle, and we have a constant. But I think we can factor it. It's kind of like factoring this. So Darren, if I was going to factor that, what would be my first term in each parenthesis? So I agree you'd have a 3x, because you got to get that 4 somehow. So 3, yeah, you could do 3x to the second. Remember, Rx is tangent. So I'm going to do 3 tangent to the second. And what would have to go here? Just tangent to the second. Okay, now our signs are going to be one of each. Okay, let's try plus minus. And two numbers that multiply to give me 2, 2 and 1. Let's check it. 3 tangent squared times negative 1, that's negative 3. 2 times tangent squared is positive 2. Negative 3 plus 2 is a negative 1. Okay, so we factored it correctly. So now we're going to set each factor equal to 0. For this first factor, I would minus the 2 to the other side and then divide by 3. Or for the second factor, I would plus the 1 on each side. So now we have tangent squared equals negative 2/3. So before we can use inverse tangent, we got to get rid of the square. Okay, so Casey, what would I do on both sides to get rid of the square? You take the square root. What's going to happen if you take the square root of each side? Look at that right-hand side.
It's going to be an I.
It's going to, what's going to happen here?
It's going to be negative. Imaginary.
It's going to be imaginary. Right? You're trying to take the square root of a negative number. We're looking for real answers here. Right? Not imaginary. So this whole part, can't do anything with it. This part, okay, same idea. Take the square root of each side. Okay, James, what would I get on the left when I take the square root of tangent squared?
I want to say tangent, but I feel confused.
Well, why are we taking the square root? We're just trying to get rid of one thing, which is the what?
Square.
Just the square. So that leaves us with just tangent. Yeah. And Joe, what about on the right? What's the square root of 1?
Tangent doesn't.
The square root of 1? No.
Oh, it's a 1. I was thinking it's
It's, okay, she said 1. Anybody have anything else they want to add to that? 1 times 1 is 1, so yes, that's partially correct. What else?
negative.
-1. Okay, so when you take a square root, remember you get 2 answers. So now we're back to having 2 answers again. +1 and -1. So I'll do them one at a time. Take the inverse tangent of +1. And I get pi/4, that's 45 degrees. And now, usually I say, okay, look for the other quadrant where tangent would be positive, which would be quadrant 3. The reason I'm not going to look in quadrant 3 goes all the way back to the beginning. They told me to give answers between -90 and 90. If I give an answer in quadrant 3, it will not be between -90 and 90. So I don't have to check for the other answer this time. They basically told me not to. Now I need the inverse tangent of -1. Inverse tangent, and I get -pi/4. Now, there's another quadrant where tangent is also negative. Tangent is negative here and here. I just got an answer here, -45. If I try to find the other answer, it's going to be somewhere between 90 and 180, which is not what they said to be between. Okay, so I don't want to go looking for the second answer because they said not to. Right, so those are the only 2 answers. If they didn't say the domain they did, then we could have looked for the other answers. Okay, but not in this case. So we'll try to do 2 more, and I think that'll show you, this one and one more will show you everything that could come up. Okay, this is a factor by grouping. Okay, factor by grouping. You look at what the first 2 terms have in common, and then you look at what the last 2 terms have in common, and factor out what you can from the first 2, and then what you can from the last 2. Augustine, what do the first 2 terms have in common?
Cosine?
Yeah, they both have a cosine. So we're going to factor that out. If you factor it out of the first term, you're left with 2 cotangent. If you factor it out of the second term, you're just left with a -3. Okay, now let's look at the second 2. Emily, what do the second 2 have in common?
They have a 3.
Yeah, we can factor out a 3. Look what that's going to leave me with. 3 times 2 is 6. Cotangent x minus 3 times 3 is 9. 2 cotangent x minus 3 2 cotangent x minus 3. For factor by grouping, that has to happen. Right? Now we can factor out what's common to both of those, okay, which is 2 cotangent x minus 3. Okay, factoring out of the first one leaves you with cosine. Factoring it out of the second one leaves you with a plus 3. Okay, so we completely factored that problem without any quadratic equation. So now, either one of these factors could equal 0. Let me do it. For the first one, you would add the 3 to the other side, then divide by 2. Okay, we'll come back to that. For this one, you'd minus 3. So now we'd use inverse cosine on each side. Or I'm also asking you, where does the graph of cosine hit minus 3? Darren? It doesn't. Cosine is always between -1 and 1. It's not going to hit minus 3. So try inverse cosine of -3, you'll get an error. Okay, now this one, I'd like to just use inverse cotangent. The problem is I don't have an inverse cotangent button. What trig function could I use that's related to cotangent? There's actually an identity for these. Or when we did unit circle trig, we always paired up cotangent with what other trig function? What's the relationship between tangent and cotangent? Yeah, it's the reciprocal. So if you take the reciprocal of cotangent, you get tangent. And if you take the reciprocal on the left, you also have to take the reciprocal on the right. All I did was flip each side. Flip cotangent, you get tangent. Flip 3 over 2, you get 2 over 3. Now we can solve this like normal. Okay, we're looking for where the tangent is a positive, so I should be looking for 2 answers. Okay, find all solutions in one period. Okay, since we've got a cosine in there, if you find the least common multiple of all of them, it'll go from 0 to 2 pi. All right, let's find the inverse tangent of 2/3. And I should get an answer in quadrant 1. 0.59. And to get my other answer, think about where tangent's positive, quadrant 3. So add that answer to pi. Okay, so you'll get 3.73. It's not too bad. It looks kind of like a really, really hard problem at first, but if you use factor by grouping, it actually works out really, really nice. Okay, generally, you'll know to use factor by grouping when you see 4 terms. 1, 2, 3, 4. You would not use quadratic equation with 4 terms. Quadratic equation is used with 3. Okay, so these 2 are pretty much the same, and that one's also very similar. Let's do this one. Okay, what's different this time is we have a double angle. Okay, before we can start to factor or anything like that, you've got to get rid of the double angle. They both have the same trig function, but one has 2x, one has x. Okay, so we're trying to think of an identity we can use to change sine 2x. Anybody remember our identity from yesterday to do that? Yeah?
2 sine x times cosine x.
Good. 2 sine x cosine x. At the same time, I'm going to bring sine to the other side. Subtract it. Now it's equal to 0. Anybody recognize what we can do now? Well, Augustine?
No.
We've done it in almost every problem except maybe one of them. And we did it in the last problem too. Sure, anyone help him out? What do we have to do now? One word, you can say it. So we already subtracted. We brought sine to the other side. These aren't like terms. Think of this as like 2xy minus x. So they're not like terms because of this extra y right there. So there's nothing to combine with subtraction. What can I do? Yeah.
Can you change something so they're all the same?
Well, since we have sines and cosines, it's pretty much as simple as you can get it. If you had a tangent in there, you'd have to change it. But it's one word that kind of summarizes. It was one of the 3 strategies I said you want to always use. So it's not the quadratic formula. It's not using an identity. Yeah? Factor. What could you factor out?
Sine.
Yep. You can factor out sine from the first part. Leaves you with 2 cosine. Factor it out from the second part. Minus 1 equals 0. Now you have 2 very simple factors. Sine x equals 0, or cosine x equals plus 1 divided by 2. Okay, we already did cosine x equals a half earlier. Okay, that's where we got pi over 3, which was 60. And we're looking for an angle in the 4th quadrant. So it's 360 minus 60, which is 300. Or 5 pi over 3. Okay, we're looking for answers from 0 to 2 pi, so I just wanted to double check. So far, we're okay. For this one, well, you could do it 2 ways. You either use your calculator or just think of the picture. Where does sine hit 0? Here and there. So that's 0, pi over 2, pi. So 0 and pi. Okay, we don't count this last one because they said not to by putting a parenthesis on 2 pi. So you cannot include 2 pi. It's a repeat of 0. Okay, sometimes the book, they might write these answers in numerical order. So 0, pi over 3, pi, 5 pi over 3. As long as you have all the answers, you don't have to write them in a certain order. Okay, any question on that? Okay, so that's the general idea of how you solve trig equations analytically. You can't solve any equation. Most of these problems that I made up had like a trick to it to make it work out nicely. And so will the problems in the homework. Okay, especially factor by grouping. Factor by grouping has to be set up very special to work. This would be almost the exact same idea as that problem. Okay, and I think this is another double angle, which I'm going to hold off on. All right, so the homework is on page 423. It's 1 to 14, 16, and 19. Okay, so we'll take a look at that tomorrow. And this finishes up chapter 7. Okay, so we'll also start a new chapter tomorrow.